One of the things we need to do is be able to measure the mass of an atom. And if you have a periodic table, your periodic table will always give you the atomic number, and oftentimes it will have a decimal number. I'll go ahead and it's a decimal number. in the box with the atomic number, and that decimal number is how much. It's the weight. It's the weight of a single atom. Okay. And that weight is given in atomic mass units. Remember, I talked about one neutron weighs about the same as one proton, which weighs about 1 AMU. So an AMU stands for atomic mass unit. Now, I learned at AMUs, but I think these days what I've seen more maybe is just the symbol U for atomic mass unit. So you're going to have to kind of make that kind of connection maybe down the road. So that decimal number is pretty awesome. It gives the how much an atom weighs, but it is, and we'll be talking more about what this is. It's an average weight. It's a weighted average of what an atom of that type of element would weigh. That average weight, is sometimes called average atomic mass, atomic weight, atomic mass. They all mean the same thing. That's the decimal number in the box on the periodic table. Well, how much is 1 AMU? Well, we've been talking about equivalency statements. Well, actually, earlier on, I should say, we talked about how all masses, including an atomic mass unit, needs to be standardized back to something. And as it turns out, actually, if we go back to the one isotopic form of carbon, carbon-12, the carbon-12 isotope has a mass of exactly 12 AMUs. And then from there, that's our definition of an atomic mass unit. So here's our equivalency statement between, I'll put both of them up here, and these are approximate. So exactly 1 AMU is approximately equal to 1.661 times 10 to the minus 24th. So that's quite a small fraction of a gram. That's as it should be. 1 AMU is very darn light. If you take 1 over this number, you actually get this number right here. We could say another thing. We could put it another way. We could say that exactly 1 gram is approximately equal to 6.022 times 10 to the 23rd AMUs. And that makes sense. 1 gram is pretty big compared to AMUs. So kind of usually look at, in this case, an equivalency statement. Does it make sense? Now, actually coming up in a part soon, we're going to talk about an important number in chemistry. And some of you, this number right here might be ringing some bells. If it's not, don't worry. But this 6.022 times 10 to the 23rd is actually Avogadro's number, and we'll be talking more about that. But this is an approximate relationship. 1 gram is approximately equal to 6.022 times 10 to the 23rd AMUs.